Hello everyone. We are in lecture 7 on strain energy principles. In this lecture, we are going to analyze a truss using Castigliano's theorem. In the previous lecture, that is in lecture 6, we have seen what is Castigliano's theorem and where it is applicable, what is the first and second theorem deals with. In Castigliano's theorem, in the first theorem, it is used to find out the deflection as well as the rotation based on the strain energy. So deflection is the partial derivative of strain energy with respect to the load. And here a problem is given, that is a truss is given, which consists of two equal triangles and it is hinged at A and supported by rollers at D. We are asked to find out the vertical deflection at point C due to a load 7.5 kilonewton. All the members have constant length. Tensile members have a cross-sectional area A and compressive members have a cross-sectional area of 2A. Okay, so here the deflection at point C due to this load is asked to find out. And we have seen in the last lecture that Castigliano's theorem is mainly used in case of bending, but it may also be used in case of axial as well as torsion shear. Also it is applicable. And here a truss is given, some compressive members and some tensile members are here. And for tensile members, the area we have to take it as A, and for compressive members we have to take the area as 2A. But the length is constant for all the members. So totally we have 5 members here: AB, BC, CD, DA and BD. Okay, first the strain energy for the axial force is given as P square L by 2EA. So this is the formula for strain energy due to axial load. And here if we take the forces away from the joint, so if, for example, if we consider this joint A, the forces away from this joint should be taken as tension and towards the joint should be taken as compression. Okay, but for assumption we will take all the forces as tensile. And here we have to find out the deflection. So what is the first theorem tells? The deflection is the partial derivative of strain energy with respect to load. So this is given here. Then this is a chain rule. Here we are just multiplying and dividing by dou P. Here instead of U we are using P square L by 2 EA, which is the strain energy due to axial force, and this dou P by dou W. Next we have to differentiate it with respect to P. So P square will be 2P. So here the P square will become 2P if we differentiate with respect to P, and we have L divided by 2EA. This 2 and 2 will get cancelled and it will be PL by EA, and here we have dou P by dou W. This is for one member. If we have to do it for the whole truss, it will be summation of this deflection in all the things. So we have to, if we want to find out for the whole truss, we have to find the summation of this deflection. Okay, now let us go into the problem. So this is the truss which was given in the problem. We are going to find out the forces in each member. First, taking joint C. So what are the members connected to C? BC and BD. The angle here it is given as 60 degree, and then if we take a line like this, the axis, this will be 30 degree and here this will be 30 degree. Okay, so first while considering, we have to consider all the member forces to be tensile. So just that's why we are taking it away from the joint. This is an assumption. But if we, after analyzing, if we find any member to be compressive, we can use the arrow like this. Okay, so first we are taking joint C. Just look into this diagram alone. We are taking joint C. So joint C has two members connected to it, as well as a load is acting, which is 7.5 kilonewton. As for now, we can take it as W itself. First, we are taking the equilibrium condition, summation H is equal to 0. Since both the member forces are inclined, we have to resolve horizontal component as well as vertical component for both member forces, since both are inclined. So horizontal component will be, this is also inclined, this is also inclined. So horizontal, for this FCB, we will have a horizontal component as well as a vertical component. Same way, for this CD, we will have a horizontal component as well as vertical component for this CD. Okay, so first one is summation H is equal to 0. So we have two horizontal components. One is FCB cos 30 and another one is FCD cos 30. Since both are in the same direction, we are taking the same sign for both, which is equal to 0. So FCD will be equal to, if we take this to the other side, it will be minus FCB. Next, we are applying the next equilibrium condition, which is summation V is equal to 0. So the vertical forces here are FCB cos 30, which is in upward direction, sorry, sin 30. FCD sin 30 is in downward direction. So it is taken as minus. And also we have a load which is W acting in the downward direction. So that is also minus W. So take upward as positive, downward as negative. You can take it as anything, vice versa also. But opposite direction should be given opposite signs. Here we have already found out that FCD is equal to minus FCB. So substituting here the value for FCD as minus FCB, we'll get FCB as W by 2 sin 30. Sin 30 degrees 0.5, that is 1 by 2. So substituting it, it will be FCB is W. FCD is minus of FCB, so that will be minus W. So one is tension, another one is compression. But for assumption, we take everything as tension. And here we got FCB as tension, so what we have assumed was correct. But here FCD is minus W, so this is by calculation, this member force is compressive. Next, we'll move on to the next joint, which is B. Same way, we are taking all the member forces to be tensile. So the members connected to B is BA, BD, BC. Okay, so here also we are taking we are considering horizontal equilibrium as well as vertical equilibrium. Here two members are inclined, so these two has to be resolved into horizontal component and vertical component. One member is already, it is vertical. Okay, so first one is horizontal equilibrium, that is summation H is equal to 0. So first we take this member, horizontal component of this member forces FBA cos 30. This is in this direction, and for this member it is FBC cos 30. This will be towards this direction. Since both are in opposite direction, for one you can take plus and for the other one you can take it as minus. So FBA will be equal to FBC. Already we have found out FBC as W, so you can substitute. So FBA will also be W. Since it is positive sign, you can take it as tension. And the next one is summation V is equal to 0. The vertical forces here are FBA sin 30, FBC sin 30. Both are in downward direction. So minus minus, as well as FBD is also in downward direction. So minus FBD equal to 0. All the vertical forces are in downward direction. So everything we can take it as negative sign. Substitute the values whatever we have found out earlier in this, and from this, after substituting, we are finding that FBD is minus 2W sin 30. Substituting for sin 30 as 0.5, FBD is minus W, which is compression. This is for understanding purpose. You can draw the diagram what we have assumed as well as by calculation what we have got. Next, taking joint D. Joint D, the members connected to joint D are AD, BD and CD. Here two members are inclined and one is vertical. Same way, summation h is equal to 0. FDA cos 30, here FDC cos 30, both are in opposite direction. So for one plus and another one is minus. So from here we are finding that FDA is equal to FDC. From joint C in the previous itself we have found out FDC as minus W. So if we substitute here, FDA will also be minus W. We have found out all the member forces, so we can stop with this. If further if you want to find out any member force, you can go for vertical equilibrium condition also. Here in horizontal equilibrium itself we have found all the member forces, so we can stop with this without finding for vertical equilibrium. Next, after finding out all the member forces, just draw a table with the member, area, length, force, dou P by dou W, PL by AE, and then the deflection. This is the formula PL by AE which we have arrived in the previous slide. PL by AE, dou P by dou W. So we have 5 members here as given in the problem. For all the tensile members, area is A. All the compressive members, area is 2A. This we have found out from the considering each joint. So this you can write it. Length is given in the problem, that is length is constant for all the members. Here we have to differentiate this force with respect to W. So if we differentiate with respect to W, it will be 1 plus 1. If it is minus W, it is minus 1. Next column is PL by AE. So P is W, L is taken as L itself divided by A. For tensile members it is A, for compressive members it is 2A E. Next, this PL by AE into dou P by dou W. So here we have already found out what is dou P by dou W. Just multiply both and we'll get the last column. So the total deflection is, we have to sum up all these values. This we have found out for each member. So the total deflection at point C due to the load is to be and that will be a summation of all the deflection in all the members. So it will be W, here you can see WL by A is common for all the members. So you can take that outside. So the first member it will be 1, second member 1, third, fourth and fifth member will be 1 by 2, 1 by 2. So you simplify this and the deflection is 3.5 WL by AE. And here you can substitute the value for W as 7.5 kilonewton, which is given in the problem. So substitute the value 7.5 and delta will be 26.25 L by AE. Thank you.